Hello friends, welcome back. Welcome and welcome. So in our this module of numbers, till now we have done 4 videos. I am sure you have watched all of them and taken the notes of it. In today's video, we will be covering about HCF and LCM. Yes. Okay. So without wasting time, let's get started. I'm sure you are ready with your pen and paper also. You're noting everything. Chalo, theek hai. Let's see. Now, suppose we have to find HCF of 24 and 60, two numbers. I hope you know the full form of HCF is highest common factor. And for the word common to make sense, there should be minimum two numbers, isn't it? We have to look for common numbers between them, and especially which numbers? Factors. I hope you all understand what is the meaning of factor. Yeah, all right. So I'm listing down all the factors of 24 and 60. 24 factors are factors means the numbers which will divide 24. 24 जिनके भी table में आएगा वो numbers. And smallest factor of any number is yes 1. And largest factor of any number is the number itself. Yes. So see, we have listed all the factors of 24 and 60. 1 into 24, 2 into 12. So like that you can list down two factors at a time. Okay, 1 है तो 60 है, 2 है तो 30 है, 3 है तो 20 है, and so on. And you can also see the factors are limited. It starts from 1 and ends at the number itself. So they are limited, means they will always be countable. In the next video, we'll be exploring everything about how to calculate the number of factors of any number. Number of factors, number of perfect square factors, number of even factors, number of odd factors, sum of factors. So many variations we will be covering in the next video. Okay, stay tuned. Next episode. Okay. Then it's time to list down common factors. I hope you saw all the blue ones. They are the common factors. The factors which are there in both of them. Correct? And then simply the last word was highest. So highest among them, highest among all the common factors was 12. So the HCF is 12. Correct? Okay. HCF is also called as GCD, greatest common divisor. Yeah. So 24, you can see if I want to write, I can write them in terms of their HCF as 12 into 2 and 60 is 12 into 5. Can you see this 2 and 5? These remaining numbers, that is 2 and 5, don't have anything in common. Because whatever common was there, we have already extracted, and that is 12. Yeah. So we can call these two numbers as nothing is common. Come on, nothing is common. So yes, co-prime numbers. Remember, co-prime numbers, the numbers which do not share anything except 1. And now technically I can also say the numbers whose HCF is 1. They are co-prime numbers. So I'm going to generalize this fact. Yeah. So if I have, let's say, two numbers whose HCF is known, that is, let's say, H. So how should I develop those two numbers? How should we assume those two numbers so that we can solve the sum quickly? We should assume it as HA and HB, where H is their HCF. But remember, A and B should not have anything in common, means A and B should be, yes, co-prime numbers. All right, cool. I hope you understood till here. Let's go ahead. Those who feel I am explaining slowly, they can watch at a higher speed, 1.5 times, 2 times. Okay. All right. Now, how do we find HCF? First is factorization method. This one, remember? So I chose 2, which could divide both of them. So I got 12 and 30. Again, I can choose 2, 6 and 15. Now I can't choose 2 because 2 won't divide 15, but I can choose 3. So 3 will divide 6 and 15 both. Now, after this stage, do you understand? Can I choose any number which will divide both 2 and 5? No. Okay, so we have to stop here. This particular stage, if I cover all these 2 into 2 into 3, this is the HCF. This way we can find for smaller numbers. All right, cool. Prime factorization method. So you have to first prime factorize. So 24 can be prime factorized as 2 into 2 into 2 into 3. That is 2 cube into 3 raised to 1. Yeah, similarly 60 could be prime factorized as 2 square into 3 into 5. Prime factorization means this base is a prime number. Means now you cannot factorize further. This is the last stage. You have to ensure that the base is always a prime number. Then that is only called as prime factorization. Now you have to look for common factors. Yeah. Since 5 was there in that 60 in 24, you couldn't see 5. You can also write it as 5 to the power 0, or you can simply ignore. What are the highest common powers? Hello, look at the word common power. So 2 cube and 2 square. So common power is 2 square, right? Okay. In case of 3, the common power is 3 to the power 1. And in case of 5, there is no common power. Yes. Or you can say 5 to the power 0. So the HCF is 12. This is how we find HCF using prime factorization. We look for highest common powers. All right. Now there is one more method, division method. This will be specifically used when you have some bad numbers. Bad numbers in the sense you don't know how to factorize. You can't find the initial factors easily. Something like 493, 2 se nahi hai, 3 se nahi hai, 4 se nahi hai, 5 se nahi hai, 6 se nahi hai. So you have to really think a lot about finding the first breakthrough, first factor. So in that case, don't waste time. Directly start the division method. This is not a normal division. Huh? Let's see what is this. So first, of course, bigger number divided by smaller numbers. 24 to the 48. Remainder 12. Now see carefully. Previous divisor was 24. Divisor. I hope you remember. 60 is dividend towards quotient. 12 is remainder. Remember those terms. So previous divisor will become the new dividend. Make 24 as the new dividend and then divide by the previous remainder. So 12 will become new divisor and 24 will become new dividend. So 12 twos are 24. Awesome. We got remainder is 0. The divisor which gave you remainder 0 is going to be the HCF. The last divisor which gives you remainder is 0, that is your HCF. Okay. Okay. Means you can also see 60 and 24 take their difference. Yes, 36. So HCF will either be 36 or the factor of 36 which will divide all of them. So among the factors of 36, 12 was the one which could divide all of them, which could divide 60, which could divide 24 easily. So HCF was 12. ऐसा भी देख सकते हैं. So if there are 3 numbers, let's say, find the differences. So we'll get 2 differences, right? इनका भी difference ले लो. HCF will be directly this or a factor of this which can divide all of these. Okay. All right. So this was about HCF. I hope you have understood what is HCF, how to find HCF, all these methods, and how to assume two numbers if HCF is known, HA and HB. Cool. Let's go ahead and let's learn LCM. M means multiple. C stands for common. L stands for least, lowest. Now when I say multiple, I hope you know another better, easier word for multiple. What? Tables. Yes, you just list down the tables. And can you have limited table? No, no. Just because we know tables up to 10, that doesn't mean there are only 10 multiples. It can go on and on up to infinity. So there is no end to it. But the smallest multiple of any number will be, yes, the number itself. 24 ones are, 60 ones are. So after listing down these multiples, basically tables, multiple समझ रहे हो? 24 into 1, 24, 24 into 2. So we are multiplying 24 with a natural number. Hence the numbers which are obtained, they are called as multiples of that given number 24. Okay. Let's list down the common multiples. Did you see? These are the common multiples. 120 was the first one, then 240, then 360, 480. All these will become common multiples. The lowest among them is 120. That happens to be the first common multiple. Lowest common multiple or the first common multiple. All other higher common multiples can simply be found by reading the table of LCM. Means first common multiple was 120, which is the lowest or least, that is LCM, then 240, 120, 2s are, 3s are, 4s are, and so on, friends. Okay. So if you read the table of LCM, you will get all the common multiples. So lowest common multiple was 120 over here, means 24 and 60. Both of them will divide 120. That is the first number which both of them will divide. Okay. So 24 and 60, both of them will divide 120. That is the least number which will be divisible by both of them. Least number which will be divisible by both of them. And 12 was the highest number which will divide both of them. Understand? So this is HCF. This is LCM. And for a set of numbers, HCF will always divide their LCM also. So 12 tens are 120. Okay. All right. How to find LCM? Again, first was your factorization method. We chose 2, we chose 2, we chose 3. Now don't stop. Keep going ahead. Yes. Now 2. This was HCF, right? So 2 ones are, and keep write 5 as it is, then 5 ones are. So at the end you got 1 1, then you can stop. These are also called as uncommon factors. So LCM is basically HCF into UCF. HCF was 12, UCF was 10. UCF is uncommon factor. So 12 into 10, 120. All right. Understood? Cool. Prime factorization. So again, this was the prime factorization of 24 and 16. Now, look at the highest power. So highest between 2 cube and 2 square is 2 cube, right? So consider 2 cube. And 3 raised to 1 was there in both of them. The highest was that only. 5 raised to 0 and 5 raised to 1. So highest was 5 raised to 1. So multiply all the prime factors containing highest powers. So in this case, LCM is 120. Got it? Cool. Now, while dealing with fractions, this is the formula. HCF of fractions is HCF of all the numerators divided by LCM of denominators. Yes. And then in case of LCM of fractions, you take LCM of all the numerators divided by HCF of all the denominators. But please remember, get the fraction is reduced form. Means if it is 12 by 36, you have to reduce it to 1 by 3 and then apply this formula. Okay, remember this. इसको याद रखना, a short note. Don't directly attack. First reduce the fractions and then apply this. All right. Understood? Okay. Now one more relation, friends, about LCM and HCF of two numbers specifically. So for two numbers, suppose P and Q, the product of LCM and HCF equals the product of the numbers. Okay, so product of two numbers is same as product of their LCM and HCF. Remember this. For example, if I take 60 and 90, this is their prime factorization. All right, correct. So we chose highest powers. So LCM is 2 square into 3 square into 5, that is 180. HCF, we choose lowest powers. Remember, 2 raised to 1, 3 raised to 1, 5 raised to 1. And now if you see carefully, if I multiply HCF and LCM, don't you feel all the factors will be getting multiplied? In short, both these numbers only will be getting multiplied. Correct? But in case of three numbers, if I do something like that, suppose 60, 90, 120. So LCM is this 2 cube into 3 square into 5 raised to 1. HCF is 2 raised to 1, 3 raised to 1 into 5 raised to 1. All the factors were not covered. Some are still left. So if I multiply these three numbers, it won't be same as HCF into LCM. Isn't it that 2 square, 3 raised to 1, 5 raised to 1 will be still left out. That will be extra when we multiply all the numbers, right? So in case of two numbers, nothing was left over. In case of three numbers, something was left over. So this result holds true only for two numbers. Remember this. Okay. So product of two numbers is product of their HCF and LCM. Okay. So for co-prime numbers, the HCF will always be 1. What does that mean? See, for example, 24 and 35, they are co-prime. Nothing is common. The HCF is 1. So such numbers are called co-prime or relatively prime numbers. In their case, HCF is 1. So LCM of the two co-prime numbers will simply be the product of both the numbers, right? So P and Q are suppose co-prime numbers. Product of the numbers HCF into LCM, but HCF is 1. So LCM is nothing but product of the numbers. So in case of 24 and 35, if I want to find LCM, simply multiply 24 and 35 because you know they are co-prime, they don't have anything in common. Understood? Yes. All right. So basically regarding two numbers, we know two things. If we know HCF of two numbers, let's say H, how to assume the numbers HA and HB, where H is the HCF and A and B are co-prime. Yeah, HA, HB, this is how I should remember, assume A and B are co-prime. And then suppose this was like A and this is like B. And product of the two numbers is same as product of their HCF and LCM. Okay. Got it. Our initial example was 24 and 60. So their HCF was 12, LCM was 120, right? So you can check. So if you multiply 24 into 60 and HCF and LCM, both of them will match. This is 1440. This is also 1440. Of course, they will have to match. I gave you example of the 60 and 90 where you saw all the factors getting covered. Correct, now? Okay. So I hope you'll remember this much. This much is good enough. HCF and LCM of fractions, all those things. So what did we learn in this video? We understood what is the meaning of HCF. How do we find HCF? All the methods, factorization, prime factorization, and division method. Then we saw what is the meaning of LCM. Correct. Then how do we find LCM? Prime factorization method. That is the best method for LCM. Then regarding two numbers, how do we plan like this? How do we assume that two numbers if we know their HCF and the relation between the product of the numbers and product of their HCF and LCM? Okay, then HCF and LCM of fractions. Okay, cool. So this much you should know very well before starting to solve any question based on HCF and LCM. I hope you understood whatever we did in this video. All right. So thank you so much for your precious time. Okay. So keep learning, happy learning. Thank you so much. Take care, stay safe. Bye bye. See you in class.